point charges plus Q1 and minus Q2 are placed as shown in the figure. Resultant electric field intensity could be 0 at point. There are 2 point charges plus Q1 and minus Q2. They have considered 2 points. When considering this point B, we know that electric field intensity is the electric force on plus 1 Coulomb charge. Then I will place plus 1 Coulomb at this place and I will consider electric force on plus 1 Coulomb. Plus 1, there is plus Q1 and plus 1. There are same charges. Therefore, there is a repulsive force. Then force on this plus 1 Coulomb due to this plus charge is in this direction. And when considering these two charges, there are opposite charges. Then there is an attraction. Therefore, resultant of these two forces could not be 0. Therefore, we have to consider point A. When considering point A, I will place plus 1 Coulomb charge on point A. Now we can consider this plus charge and plus charge. There is a repulsive force, and when considering these two charges, there is an attraction. I have considered only this plus 1 Coulomb. Now it could be 0 because of opposite forces. But forces should be equal and opposite. Therefore, force on this plus 1 Coulomb due to this charge should be a greater value because of there is a large distance. Therefore, Q1 should be greater than Q2 and the neutral point could be A. Then A is Q1 greater than Q2. We can get second answer is the correct one. A charge plus Q is uniformly distributed along a very thin non-conducting circular ring of radius r and charge minus Q placed at the center of the ring. Now a very small part containing a charge delta Q is removed from the ring as shown in the figure. The electrostatic force acting on charge minus Q at center of the ring is. When considering the ring, there are equal and opposite forces due to charge point charges on the circle. I will consider this minus Q charge, and when considering these 2 point charges, we can get that there is a plus charge along the ring. Therefore, there is an attraction in this direction and this direction. Therefore, it is cancelling. But when considering attraction in upward direction, there is no downward force because of this part is chargeless part. Therefore, the resultant force should be in upward direction and resultant force should be equal to the force given by this removed charge part and it should be opposite. Then we can get resultant force 1/4 epsilon. Removed charge is delta Q into Q divided by delta Q is simple. Delta Q divided by R squared. Radius is given as capital R along the plus y direction. Then we can get fourth one is the correct answer. In fifth one, they have given that minus y direction. The resultant force should be upward because of there is an attraction to plus charge and this minus charge between. Figure shows three isolated systems A, B and C, each having a point plus Q uniformly charges conducting shell of charge plus Q. If the respective electrostatic force between the point charge due to the shell are given by FA, FB and FC. When considering first one, the charge is on in the shell. We know that charge in a conducting sphere will spread on the surface. Therefore, there is no an electric field a point like this. Therefore, FA should be 0. But second one and third one, we have considered different radius r over 2. Charge is at same distance from this radius and same charge plus Q. When considering an outer point, we can get that the total charge is at the center of the sphere. Therefore, we have to consider same distance from this center and this center. Therefore, if B should be equal to FC. Then we can get second answer is the correct answer. For a small conducting sphere of mass m has a plus Q charge. The sphere is hung from an insulating thread of length L in a region where there is an electric field intensity E in vertically downward direction in addition to gravitational field, and is allowed to oscillate as a simple pendulum. If the period of small oscillation of the this pendulum is T, then we have to find the period. We know that period of simple pendulum 2 pi root L over G. But now we have to consider the acceleration in downward direction due to gravitational acceleration and due to the electric force. When considering the electric force, we can get that F equals QE. Then acceleration due to electric force is force divided by mass, QE divided by mass. There is an acceleration in downward direction, therefore we have to add downward acceleration QE over m to this part. In resultant acceleration, resultant gravitational acceleration on the object should be G plus, charge is given as capital Q, G plus Q E over m. Then we can obtain fifth one is the correct answer. Number 5. The figure shows the positive point minus slight charge moving along a straight path between two fixed equal negative point charges. The variation of magnitude f of the force on positive charge due to the two negative charges with the distance is best represented by charges are moving along the path given in the figure. It is like this: minus charge, sorry, plus charge and there are two minus charges at A and B. We know that there is an attraction between plus and minus. Therefore, it will attract to this charge and this charge at this phase. Therefore, when moving in this direction, the resultant force is decreasing and becomes zero at this phase, and again it will increase. They have considered only magnitude. Magnitude should be like this, but if you are considering direction, this part should be minus because of when considering the charges at this side, there is an attraction in this direction, and if the charge is in this side, there is an attraction in opposite direction. Then answer is 3. Which of the following statement made about electric field lines is false? Electric field lines can be either straight or curved. Yes, it is correct. You have to find the false statement. Electric field lines can be parallel to one another. Yes, we know that when considering a field like this one, when considering a large charged plate, we know that there are parallel field lines. The third one, electric field lines can form closed loops. No, electric field lines are not making closed loops. Those are starting from a plus charge and ending at a minus charge. Therefore, incorrect statement is third one. Then I will explain fourth one and fifth one. Fourth one, electric field lines begin on positive charge and end on negative charge. Yes, it is correct. Fifth one, electric field lines can never intersect with one another. Yes, it also correct. 4 particles each having charges of plus q are placed on 4 vertices of regular pentagon as shown in the figure. The distance from center O of the pentagon to vertex is A. The electric field intensity at center of the pentagon is. There are 4 charges. It is a regular pentagon. There are 4 charges, plus q, plus q, plus q, plus q, and there is no any charge at this stage. When placing plus 1 Coulomb, we know that force on plus 1 Coulomb is the electric field intensity at corresponding phase. Now, there is a repulsion due to this charge, and there is a repulsion due to this charge and this charge. Now we can get resultant force should be in this direction. You have to draw the corresponding force line in given figure, and you can identify it is in OE direction, and you can identify that this force and this force cancelling out, equal and opposite pentagon. We can consider that if there is a charge at this place, same charge, if there is a positive charge at this place, it is a regular pentagon. Therefore, there is no resultant force. But now there is no charge at this place. Therefore, the resultant force should be equal to the force acting by the positive charge placed at this place. It is 1/4 epsilon q over, distance is given as a, q over a squared, and it should be in the EO direction. EO direction. Then answer is 2. 2 point charges of plus q, each are held at vertices B and C of an equilateral triangle ABC of side length A, and the other point charge of plus q is held at point P as shown in the figure. A zero resultant force will act on positive unit charge placed at point A when the distance AP equals to. We can get that when placing plus 1 Coulomb at this place, there is a repulsive force due to this plus q charge, and there is another repulsive force due to this plus q charge. Same force. Then we can get upward resultant force. We know that this angle is 30 degrees. Then F cos 30 times 2, upward force. It should be equal and opposite to the downward force on this plus 1 Coulomb charge due to this third plus q charge. I will consider it as F dash, then it should be equal to F dash in opposite direction. Then I will substitute F value 1/4 epsilon product of charges q into 1 divided by distance A cos 30 root 3 over 2 into 2 should be equals to F dash is 1/4 epsilon q into 1 divided by, you have to get a squared, r squared. Now we have to find r value. Then we can cancel out 1/4 epsilon q, 2 and 2. Then I will subject r value. R should be a squared divided by root 3 square root. A squared square root is a. Root 3 square root of root 3 is given in the answer like this. Then answer should be 3. 4 charges each of plus q are fixed at the vertices of a square ABCD as shown in the figure. A movable particle with charge minus q is placed at the center of the square. If 2 charges at A and B are vanished simultaneously, which of the following is not true regarding the movement of the particle with minus q? Neglect the gravitational effect and air resistance. There are 4 particles plus q. Therefore, the resultant force on this minus q is 0 at initial situation. There are 4 attractions like this. But A and B are vanished, then these charges are removed. Then we have to consider only these 2 forces. Therefore, resultant force is in downward direction. It will accelerate in OP direction. Then answer is 1. They have asked that which of the following is not true regarding the movement. First one is correct. It is the correct statement. Speed of the particle becomes maximum at P. Yes, it is correct. P means this point. We can observe that this will accelerate continuously. The magnitude of acceleration is changing, it is decreasing, but velocity is maximum at P. After passing P, it will accelerate in opposite direction. It means it will decelerate. Then second one is correct. Third one, once it arrives at P from O, P from O means this point to this point, it will move further distance of magnitude OP along PO direction. Yes, it will move and another distance due to the velocity. It's also correct. Fourth one, it will always have maximum acceleration at P. It is false. P is this point. At P point, there are equal and opposite forces. Therefore, resultant should be 0. Fourth one is incorrect. Fifth one, it will again return to O. Yes, after passing this point, it will move in opposite direction because of these two charges are attracting. There is an attraction force on minus Q after passing this point in upward direction. Then incorrect statement is fourth one. The magnitude and the direction of electric field at point A due to the point charge distribution shown in figure, we can identify there are +1 and +1, two charges in this point. Therefore, when placing one +1 Coulomb at this place, the force will equal and opposite due to these two charges. Then we can cancel out. Same thing, plus Q, we can cancel out. There are equal and opposite forces due to these two charges. Plus 3Q minus 3Q, we can cancel, plus 3Q plus 3Q, we can cancel out. But when considering these two charges, plus Q and minus Q, when placing +1 Coulomb, there is a repulsion force due to this +1 and there is an attraction due to minus Q. Therefore, there is a resultant force in this direction. Therefore, electric field intensity should be in this direction, and we can write it 1/4 epsilon charge Q divided by distance A squared. This field intensity is due to this positive charge, and there is another field due to this one, same magnitude. We have to multiply by 2. Then we can cancel out 2 divided by 2, 1, 2, Q over. So they have given multiplied the answer without cancelling. 2Q over 4 epsilon A squared. In this direction, then answer is 1.